Before we start today, let's go through the first part of, I'm going to take one or two from each of the first 4 or 5 sections that we're looking at. So starting with, I'm going to take 1B and 1C. So let's look at that right now. So if I have minus 15 squared, okay? So minus 15 squared, what is minus 15 squared? What does it mean to you, actually? What's it asking you to do? Very good. So let's start with that. So minus 15 times minus 15. Okay? So when I have it, as I've written it out, that looks like it's in brackets, correct? So therefore it's minus 15 times minus 15, which would equal 225. Fair enough? Okay? And the next question says this. So what does that mean to us? Does it mean the same thing?
No, it's just squaring the number of the sign.
Exactly. Here's the easy way to think this through. Okay? And Jesse's absolutely right. I'm going to square this and then I'm going to put the sign with it. But what I suggest you do is look at it like this. That's like saying minus 1 times 25 squared. Okay? Which means then I go minus 1 times 625, which is equal to minus 625. So I'm going to square this first and then times it by negative 1. That's the easy way to think about how to do this when you don't have brackets. All right? Okay, so the difference between the two is this one is minus 15 times minus 15 because it's in brackets. This one is 25 squared times negative 1. Okay, so that's the first part. The second part, express your answer as an integer or a fraction. Let's look at, okay, well, let's look at B. Again, I ask you, what does that mean? Okay, so let's go minus 3 times minus 3 times minus 3, which is equal to 27. Okay, 27. Right? Okay. Go ahead, Dawson.
I have a question on like 3G.
3G?
Yeah.
Perfect. Okay. Square root 16 over the square root of 144 equals. What's the square root of 16, Dawson? Square root of 144. Now I'm going to reduce my fraction to 1/3. Okay, so the answer in the back, without showing you the solution, said 1/3, and you probably said, well, how the heck do you get 1/3? All right, but we are still working with fractions, so we have to reduce fractions into their lowest terms. And so that's what happened here. When I took the 4 over the 12, I got 1 over 3. Okay?
Can we do 4D?
4D?
Yes.
Sure. I have the cube root of 64 times 125.
Yeah.
Okay. Let's do this. Let's do this the simple way. All right? The simple way is this. Let's look at it like this. Cube root 64 times cube root 125. What's the cube root of 64? Times the cube root of 125? 5? 20 is your answer.
It's in the back, it said something. It was 5. How's it different? Oh, how's it different?
Okay. So, everybody take a peek at this here, right? I'm breaking it down. Somebody in their infinite wisdom would probably go 64 times 125 and then find the cube root of it. And that's fine. But if I'm trying to do the most that I can without a calculator, I'm going to find the cube root of 64 and the cube root of 125. Again, think this through. I need a number that I multiply by itself 3 times in order to get that. So if it works out to an actual whole number, your choices are pretty limited. Because 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed are fine. What's 6 cubed? All right, now we've got to start thinking. All right? So generally, they're going to give you numbers that work out nicely for you, at least in the beginning. So you want to work through that. All right? Anybody else have any questions off that page?
Can we do like the ones we compared?
Yeah.
Those are the ones I don't understand.
All right, fair enough. So let's start with each.
Yeah.
So I have the cube root, 125y cubed, right? Okay, so let's break it down into its parts. Okay, so I'm going to do this logically, and then I'm going to show you how to do it using different methods of math. Okay? What's the cube root of 125? We just did it. The cube root is 5. What's the cube root of y cubed? 1y. Done. There's your answer. Okay?
What would you do for
Uh-oh.
No, don't. What? Yeah.
It's creepy.
And that's all we
And that's when
That's when it goes hooks up their
That's
iPod and
and starts playing spooky, scary
That's why
Let's go for sure.
It's Charlie.
Come on, man. Go
Finally come after we called for so many times. Shut, that's not funny.
Very funny.
What?
I think it's on.
You know how many times you people did that?
Callie, can you move up a stitch,
A
please?
lot. You were sitting
Yeah,
there
yeah.
with us, we were
Yeah.
we were talking, you know, we made a. Yeah, we made a.
Oh no, it's broken.
We did it in the
Change
dark.
that in about something goes bad.
Yeah, and it was like, yeah.
I heard something
We
about
rated it. Yeah, based on it.
I heard something about Snoopy haunting this place.
Okay, let's get back at that.
Don't worry.
Alright, so we end up with 5y. So that's the solution for 125y cubed. Now, what I was trying to show you yesterday was, and it makes more sense with the y's. How do I write the cube root as a fraction or an exponent? Right? So the cube root, this here, can be written as an exponent to the 1/3. Okay? So what's 1/3 times 3? That's y to the 1. Okay? So that's the other way in which I can do that. So let's take a look at the next one. Cube root 729 a cubed equals. So we need the cube root of 729. 9? Cube root of 729 is 9. Cube root of a cubed? Okay. So right now, just looking at all your questions, that's all you need today. You don't have to get into anything any more complicated than that. All right, it's going to work out evenly every time. What I showed you yesterday where you had like y to the 5th or y to the 6th or y to the 7th, we'll get into that. I just need you to see it ahead of time so that it's not brand new the next time I review it.
Can we do 3i? I'm not sure if I can.
3i?
Yeah.
Sure. Square root 49a squared over the square root of 169b squared, is that right? Casey, what's the square root of 49?
7,
Square root of a squared?
8,
Square root of 169?
13,
Square root of b squared?
8,
It's just something.
Oh, thank you.
It's like, yeah. I think it's
Like,
yesterday we did like the whole,
where it just,
yeah.
the big
the bottom.
triangle thing.
Yesterday with the.
Okay.
Like getting-
Yeah, we're not done. It's gonna get more complicated. I get that. But what we're doing, what we want to do is we want to be able to start with this, okay? And then when it gets more complicated, you'll have a better understanding of it. All right? Okay, girls. Okay, so this leads us into today. You should know all of these already. All right, I'm guessing that you probably know them all, but we're going to go through it anyways, and let's look at how this works. I'm going to go through all of the rules for exponents. Okay? Beginning with this one. When I times two variables that are the same base, so the a's are the base, and I have a to the m times a to the n, what do I do with the exponents? For me? I add them. All right, so let's look at a concrete example of this, okay? Because there are mistakes that get made here, and I'll lead you into them. All right, so I have 2 cubed times 2 squared. What is 2 cubed actually? Well, I just need to leave the base. What does it mean? What am I asking you to do? 2 times 2 times 2. 2 times 2 times 2. So how many 2's do I have? Okay. And then 2 squared is? 2 times 2. So how many 2's do I have? I have 5. Right? 2 to the 5th. Okay? The mistake that gets made is everybody assumes that you multiply those together. But if I write it out like this, I can clearly see that I only have 5 2's. So it's 2 to the power of 5. So when I have the same base and I multiply these guys, I add the exponents together. You cannot use this rule if this is apples and oranges. If that's an A and a B, you can't use that rule. Right? You can't multiply these guys together. You can't put their exponents together. You have to solve them separately. So just remember that. Okay, you'll understand as we get going here. Quotient rule. I have a to the m over a to the n. What do I do with the exponents? Okay, so I've got a to the m minus n, right? So I have 5 cubed over 5 squared. Right? How many 5's do I have on top? How many 5's do I have on the bottom? So if I subtract the exponents, I end up with 5 to the power of what? 1. Cancel, 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 cancel. What am I left with? 5 to the power of 1. Okay? We've already talked about this at length yesterday. What does that actually mean? What do I do with the exponents here? I multiply them. Exponent to an exponent is m times n. Okay? Let's look at an example. 2 cubed squared. What does 2 cubed squared mean?
2 to the 6.
It is 2 to the 6, because you're multiplying them, but right. But what I'm asking you is if I ask you to expand that, what does it actually mean?
2 times 2 times 2.
Not yet. You're too far before that point. Okay, what does a squared mean?
8 times 8.
8 times 8. What does 4 squared mean? For me?
4 times 4.
4 times 4, right? 5 squared is 5 times 5, correct? Okay, so what does 2 cubed squared mean?
2 times 2 times 2. And then
No. Casey, no. 2 cubed times 2 cubed, right? That's what it means. So then using the first rule, I add the exponents, what do I get?
2 to the power of 6.
To the power of 6, or I could have multiplied those together. Okay, so again, important to remember that. A couple other little guys that you want to know for sure. a to the 0 is equal to what?
A.
What do you think it is? 0? Everybody think it's 0?
Because there'd be A times.
Oh, because you're reading ahead, are we?
Please excuse the interruption. Basil, Steve Diggity, please, for the office.
One.
Representative. Basil,
Okay,
Steve
the answer's
Diggity,
1.
please.
Let's look as to why. 2 to the 4th over 2 to the 4th is equal to. What do I do with the exponents? What do I do with the exponents? I subtract them, so I get 2 to the power of what? 0. I agree. But what is this? 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2. Agreed? 1, 1, 1. I'm left with 1. Okay? Any number divided by itself is going to give you 1. Well, that's what this is. That's if I were to take any number divided by itself, I'm going to get 1. Okay? The last one. This is the one that is the most confusing to everybody. They don't understand why, so we'll just go through it slow so that you get it. A to the negative m. If I want to write that as a positive exponent, I write it as 1 over a to the m, and it becomes positive. All right? If I have 1 over a to the negative m down here, I can move it to the top and make it positive. All right? To change an exponent, bless you, to change an exponent from negative to positive, you either put it above the line or below the line, but on opposite side as to where it was negative. All right? Okay, and that's an important one. This is the one that we mess up all the time. Okay, so to make any one positive, you just put it below the line. A to the m. Does everybody understand that? That's the hard one. That's the one everybody finds difficult. Look at page 67, question 1a. What's the answer to 1a? Dylan? Pay attention. What's the answer? I just told you what it should be. What is it? How do I make it positive? Go ahead. What is it? Yeah. There's your answer. How do I make 4 to the negative 2 a positive exponent? I put a 1 over it. 4 squared.
So is that the answer, or is
Yeah.
it? Or do you have to like plug that in and that's your answer?
No, well, they may ask you to expand it or simplify it. It'd be actually 1 over 16. So 4 over the negative 2 would be 1 over 16, because that's what 4 squared is 16. But all they're asking in that first part is just to write it as a positive exponent. So all you have to do is just flip it, either take it above the line or below the line, depending on where it is. Okay, so what about this? How do I write that so that I have the exponent as positive?
And that's 1 over 3x.
They already positive.
One of them is and one of them isn't. Good point, Marshall.
1 over 3x.
Okay? Does that guy affect this guy? That's my question.
No.
Does it? Okay. Not sure, correct? We're really unsure of that, right? What if I wrote that as this? Is that the same as that?
No.
No. The difference being that negative 3 is for both right here. The negative 3 for this is just for the x. So how would I write this? Because what is the exponent on 3 right now?
One.
Plus 1, isn't it? Right? So I just leave it as is. The only exponent I had to fix was the one on the x. Does everybody get a grasp of that?
So then in the brackets, it would be 1 over 3x, or brackets 3x positive. Okay.
Exactly. Okay? Let's look at h. Okay? So, what needs to move?
3 and the y
Why does the 3 need to move?
is negative.
Yeah? So every time you've written a negative in the last 3 years, you switched it and you put it to the bottom of the fraction and it became positive.
No.
Okay, so that's what I'm getting at, right? Why am I switching these? Because the exponent is negative. Not the number can be negative. The exponent is negative, so which one of these do I have to actually move? Y negative 4. So what does it become? Negative 3x squared y to the 4. And you're done. The negative can stay there. It doesn't affect exponents if it's in front of the number. Okay? So like I said, this is the part that you're going to struggle with today. It's the part that we have the difficulty with. Because all the other ones you've already done, right? Grade 9, you probably did some of those already. But this one is kind of a new one to throw at you. Fair enough? Okay. I don't want to go any further than 4.2 because that's a lot. And again, 4.3 I guess is the same thing. But I'm not worried about it right now. Let's just worry about 4.2. It is extremely imperative for all of you to get this down pat. Because then when you get into grade 12 pre-calculus, all right, for those of you, and most of you will, this comes back in grade 12, all right? And they use it for a different principle, but it's the same rules that apply to do it. So you've got to really know your exponent rules, okay? So you need to finish 4.1 and 4.2 for tomorrow, and then we'll look at 4.3 tomorrow. 4.3 is actually just exactly what I did earlier, is this right here. They just haven't shown you that in the book yet. That's the next lesson. So we've already seen it and done it. Okay? All right?